Okay, so in this question, we're going to do your turn, which is moments with some algebraic distance. So first thing you want to do here is check that you can draw this diagram nice and accurately. Got a uniform ladder AB, maths 20, so 20G, rough horizontal ground, a smooth vertical wall, and we've got some fractions here. So it says, for example, a mass is attached to the ladder. So we've got this 20 kilogram one, and then we've got another one 3/4 of the way up. So one way that we can handle this, we could draw, because it's uniform, we could draw our 20G of the weight of the ladder in the middle, and then our 10G here. And you might want to just call these, for example, 2A, A, and A. You could just label the distances in that way. Okay. As we said again, it's another one against the wall. It's on the point of slipping. So point of slipping is the signal that we're dealing with equilibrium. So again, we'd do R and mu R and S, and that's kind of the setup for the question. So let's go over to a neater version, and they've actually drawn this one the other way around. So I'm going to just change that to mu R, and I think I'm missing that 10G, aren't I? So I should also have a 10G there. So that's our question. So we're trying to find the angle that we make with the ground. So something a little bit different. We haven't had one like that before. But again, we're going to do our normal steps. So if we do our up equals down equilibrium, we've got what? We've got 30G equals R. If we do the left and the right, we've got S, and that's going to be equal to friction, mu R. So 1, 2, 3, 4, 5. Perfect. We'll do the moments next. So we're going to say that clockwise equals anti-clockwise. If we're going to the left and down, these are actually anti-clockwise ones now, aren't they? So hopefully you're at the point now where you feel quite confident in how to resolve those based on the earlier videos. So what is that? That's a 20G cos theta, and then that would be 2A. So the distances we said, let's call it 2A and A and A. So that would be 20G cos theta times 2A. And then the other one would be 10G, because it's kind of doing the same thing. You can copy a lot of the stuff here. So 10G cos theta times 3A. What's that? That's a 40, and that's a 30. So that's 70 altogether. Have I got some numbers somewhere so I can check? No, but I'll just double check my work here. So I've got 40, so that should be 70G cos theta is the total sort of anti-clockwise moment. The clockwise moment then must be being provided up here. So that one there, if I did theta, that would be opposite. So that's S sine theta, isn't it? S sine theta. So S sine theta. And how far away is it? It's 4A. So that must mean that that is equal to 4. Oh, I've forgotten the A's on here, haven't I? That's why we've got to check our work. No M's? No, no M's in this one. So 4AS sine theta. So I can do that. I can then cancel those A's, as we often do. And I should now be in a position then. So if I use this one, and this final equation here, I should be able to get theta on its own. So what I might do, because I've got theta in two places, tan theta would be the way to resolve that. So if I divide by 4 on both sides and I divide by cos on both sides, I would get S tan theta. Yeah, I would get S tan theta is equal to, well, it's 35 over 2 at the moment, 35 over 2G. I think that's correct. Yeah. And then this S, we should try and kind of get rid of this S, shouldn't we? That would help things out. So I could get tan theta equals, I'm just going to call that 17.5 to make it slightly less annoying. So 17.5 G over S. And S is given by mu R, as we can see up here. In fact, you could do a little bit better than that. You could say S equals 30G mu. Now I'm hoping somewhere we've got the coefficient of friction, because I don't have that at the moment. The coefficient of friction is a half. Okay, perfect. So S equals mu R. R is the same as 30G, and we've said there that mu is a half, so that's just 15G, isn't it? Okay, so now I can use that number there. So it is equal to 17.5 G over, is that 15G? Okay, so tan theta equals 17.5 over 15, or 7 over 6 if you prefer. So theta equals inverse tan 7 over 6, which is going to be, do I actually have the number somewhere? No, I do not. But we'll just work it out for the sake of completeness. So 7 over 6 is 49.398. 3987. Good tip with this is you can always just give things to more decimal places or significant figures than you need to, and then round afterwards is a very safe way of doing it. So I'm going to say is equal to 49 is to 2 significant figures. Okay, so 49 degrees. So let's just take a quick look at how we did that question there. So we had algebraic distances again. We had 2 things on the ladder, so that saved us some time. We had the wall, so that always operates the same sort of way, so hopefully you should be getting quite confident by that. The up, down, left, right, those two tend to go together, and then you substitute it with a moments equation. And yeah, that's pretty much it. So hopefully now you feel quite familiar with algebraic distances, and you would be able to apply it to pegs and to walls.